We have two sections to look at today. The first one is dealing with slope of a line. There are three techniques for finding slope of a line. Depends on what you're given. If you are given 2 points, you use the formula. If you are given the equation, you isolate the y, and it will be the coefficient of x. And if you're given the picture, you can count between points. All right, so the first one they're giving us is, they're giving us 2 points. So we are given -9, -9, and 9, -4. And we're asked find the slope, right? Hopefully you guys remember that for slope, our standard letter that we use is M. And the formula for slope is the change in y's over the change in x's. I usually do it y2 minus y1. It doesn't matter which way you do it, if you do y1 minus y2, as long as you do the same thing in the numerator and the denominator. That's the thing. What I usually do to help myself here is I go ahead and label my points. So I'm going to call this point 1, which gets an x and a y, and I'm going to call this point 2. And then I just plug in. So my y2 is -4, minus from the formula. My y1 is a -9. Just be careful and don't lose a sign there. All right, my x2 is 9, minus from the formula. My x1 is a -9. All right, and now we just have to clean up. Remember, your minus and negative is going to turn into plus. And so this one gives us -4 plus 9, which will be a 5. And this will give a plus. So we should get 5 over 18. All right, so that is using the formula. I thought I would skip some of these because they're all the same. You're just plugging into the formula. Label your points and be careful. Make sure your y's are on top. Okay, so I'm going to go down to question 6 because there will be more where we have to do that skill. All right. This is one that I thought I would do because it is a special case. Right? It is still the same kind of question. It asks us to find the slope between these points. So 4, -8, and 8, -8. Right, so write your formula. Change in y's, y2 minus y1 over change in x's, x2 minus x1. Label, so this will be x1, y1, x2, y2. And then plug in. So I get -8 minus a -8. And down here, I get 8 minus 4. We'll do that one first, it's easier. Minus a negative is going to turn that into plus, and this gives us a 0 on the numerator. 0 divided by anything gives us 0. And this is from a horizontal line. A horizontal line has a 0 slope. When you look at the points to begin with, because my y's were the same, that might click for you ahead of time. If the x's were the same, like if both of the x's were 4, I would get a 0 in the denominator. And that would make it undefined, and then it would be a vertical line. So, we'll check. Just make sure. So the slope is 0. Okay. And it's undefined. When it is undefined, you write D and E. So that's what the software is choosing. All right, so the next kind of question, they are giving us the graph. So we're going to find points and count. You do want to find points that hit at the corners of the boxes. And I'm going to blow this up just so that's a little easier to do. Right, and hopefully you will see my pointer on there. I'm not sure if it comes through or not that I'm using for my mouse. So like an arrow. Right, I'll write down which points I'm going to use, so if my mouse doesn't, you'll get the idea. All right, so I want points that hit at the corners. The reason you need points that hit at the corners are because you want to move a whole unit. You don't want to move a part of a unit. Right, so right now I have my mouse on 3, -2. And I see that's a nice corner, and I'm going to move up. And the next one I see that looks clear to me is this point, 0, 2. And writing the coordinates, I mean, you could calculate it from there, but we won't. We're going to count. And so I'm starting at 3, -2, and I'm going to move up to get to this other point. So I'm going to go, and you're counting vertical change over horizontal change. So vertical change, if you go up, is positive. If you go down, it's negative. And we were starting at 3, -2. So I am going, and I'm trying to get to 0, 2. So I'm going up 1, 2, 3, 4. That lines up with the 2. And then I'm going to go to the left. Sorry, it moved my mouse when I wrote. All right, so I went up 1, 2, 3, 4. Now I'm going to go to the left to get to the point. 1, 2, 3 to the left. Going to the left is negative, going to the right is positive. So I have to do a -3 there. And it doesn't matter where you put your negative. So let's just count again so that I don't have to write anymore. So I started here, and I went up 1, 2, 3, 4, and then I went left 1, 2, 3. If you had started the other way, if you had started at 0, 2, because that one clearly hits at a corner, and if you wanted to move down to this one, you could have. It would have gone down 1, 2, 3, 4. So that would have put the negative on the numerator. And then you would have gone, all right, we'll count again because it moved my mouse. 1, 2, 3, 4. And then we're going over, but we're going to the right. 1, 2, 3. Going to the right is positive. So that would have been just starting at the other point. So it doesn't matter which one you start at. These are the same. When you only have one negative, it's negative. So a -4/3. And there we go. So when you have the picture, find points at the corners of the boxes and count from one to the other. Right? Or you can write them down and calculate. I think the counting is easier. It's not so easy trying to show it to you because it switches as soon as I write. It moves my mouse. And I'm not sure you're seeing the mouse. Okay. And if you're not, it's kind of a waste of time to go through that. All right, we'll do one more of these, and then we won't do any more of these. All right. So I am going to pick 2 points clearly that hit at the corners. I see 4, so 0, 4. And I'm going to use 2, 0. All right, so if I start at the 4, you should do vertical change first. Right, I'm going to have to go down 2. That'll be a -2, and I'm going to go to the right 1, which would be positive. So it will be -2 over 1, which will be a -2. So I started at 4, I went down 2 to the right 1. Good. All right, and I'm gonna skip this one. It's just too many. This does give you some nice cases. This one is a positive slope. A line with a positive slope climbs as it goes to the right. This one is an example of your horizontal line, which has a 0 slope. This one is another line with positive slope. This vertical line has undefined slope, and that's when you write D and E, but the answer is it's undefined. The next one here is an example of a line with a negative slope. As you go to the right, it goes down. All right, I'm not going to count a bunch on those. All right, 10. They're bringing in another concept now, and we're going to find the slope, but they're going to say things about parallel or perpendicular. And so we're going to write eventually equations of lines, but lines that are parallel lines have the same slope. Right, and parallel lines are like railroad tracks. They're the same distance apart forever. Okay. Perpendicular lines have slopes that are negative reciprocals. So opposite signs and flip them over. And it doesn't have to be either one. All right, so we're going to keep that in the back of our mind. And this one, so question 10 asks us to find the slope of the line parallel to the line between these points. So we're going to have to find the slope with these 2 points, and then parallel would mean that it's the same. So this is the skill we did earlier, and we labeled our points to make it a little easier. And then we wrote our formula, changing y's on top. And this is a formula you need to make sure you know. And then you just plug in. So 5 minus 7 over -3 minus a -2. Be careful with your signs. Right, 5 minus 7 is -2. This will make plus, and that is a -1. A negative divided by a negative gives you a positive 2. So our slope of this line is 2, and they used the word parallel. Find the slope of the line that's parallel. So parallel would have the same slope. So it will also be 2. All right, so just trying to decide how much of this we want to do. We'll go ahead. Right, it says given below are descriptions of 2 lines. This one goes through these 2 points, this one goes through these 2 points, tell the slope of each one, and then say are they parallel, perpendicular, or neither. All right, so we're going to have to calculate that slope 2 times. All right, so for line 1, we have the points 10, 10, and negative 10, negative 6. Label. Sorry, this should have been 1. Right? Every point gets an X and a Y. So this is point 1. So this is X1, Y1. This is point 2. Point 2. So it gets X2, Y2. All right. So M equals change in Y's over change in X's. And we plug in. So Y2 is negative 6 minus Y1 is 10 over X2, negative 10 minus X1, 10. Right. This is just a minus 10. So it was not minus a negative. So minus 10. So that's a negative 16 over a negative 20. You need to clean it up. So your two negatives give you a positive, and it has a common factor of 4 to reduce. 4 into 16 will go 4 times, and 4 into 20 will go 5. Make sure that you could do that on your calculator if you need to. We'll skip the signs, but if we do 16, fraction button, 20, enter, 4/5. And we could have put the sign. Remember, this is your negative sign down here. Okay, and it would have cleaned up signs for us. All right, so that is the first thing we had to do. But to answer the question, so this one is 4/5. Then we have to do the same math with the line 2. So we have 0.58 and negative 50. We label, so X1, Y1, X2, Y2. Write your formula. M is change in Y's. Y2 minus Y1 over X2 minus X1. And plug in. So 0 minus 8 over negative 5 minus 5. So we have a negative 8 over a negative 10. Clean up your two negatives. That makes positive. These have a common factor of 2. 2 will go into 8 4 times. 2 will go into 10 5 times. Your slopes are the same. So these are going to be parallel lines. So this one is 4/5. And so it is parallel. Good. I am going to do just this one more of these. And this one is a special one. The reason I know that when I look at it is my X's are the same. And then on line 2, my Y's are the same. So those are going to give my special conditions. So line 1 goes through 8, negative 6, and 8, 2. Right, on this one, the X's are the same. X's are in the denominator. When you get 8 minus 8 in the denominator, you get a 0. So you can stop there and you don't even have to plug the rest of this in. So my coordinates matched, okay? And these were in the X spot. This is undefined. And this is a vertical line. Right. The other situation has the Y's the same. this one, the y's are the same, which is going to put a 0 in the numerator. And we don't even, it doesn't matter what the denominator is. 0 over anything equals 0. So this one is a horizontal line. And so it's not going to be either, sorry, it is going to be one of those. But you can't do it just like normal, all right? So you have a vertical line, which is here. You have a horizontal line, which is here. And you have to pretend that's really straight up and down. They come together at a 90-degree angle, so they are perpendicular. That is what perpendicular lines do, but it's kind of a different approach you have to deal with on this one. I didn't ever look at the answer. So this one is the undefined. So that's our vertical line. This one, 0 slope, is horizontal line, and they are perpendicular. Okay, so special case. All right, and I'm just not going to calculate all those. All right, we'll move to 13. And these are giving us the other format for lines. So they're giving us equation of the line. All right, and they're asking us the slope for each one. If you are in what's called the slope-intercept form, which has y isolated, then your slope will be the coefficient of the x. You have to be in this form, though, to read it off. So our first one is, so our slope here is -3. Line 2 is not in this form, so you have to do some algebra with it. You need to isolate the y. So you can either move the y, move the x, or you can just start isolating the y on this side. Let's bring it down so we have a little bit more room. So it's going to be just some algebra. So we have x equals -3y plus 4, right? But we want to isolate y. So I'm going to move the 4 over. So I have to subtract 4 to move it. So I have x minus 4 equals -3 times y. And then we have to divide by -3. Now, when you do lines, they usually divide under each piece. Right, so this will be -1/3 times x, and this will be 2 negatives, which make it positive 4/3. And this is equal to y. Now y is isolated, you can read off the slope, and the slope will be the coefficient of the x. So this time the m for line 2 is -1/3. Right, and just making sure I did okay here. That was a positive x. Okay, it looks good. So our slopes, we had -3 for 1. We have -1/3. These are reciprocals, but they have the same sign. They are not reciprocals with opposite signs. So they are not going to be perpendicular. I'm jumping to the last question. And they're trying to get you to fall for it right here. If this was y equals and then x here, you would just look and know the answer. They would be the same and it would be parallel. But that was not the case. This was not y isolated. So we had to do some work. So our first one was -3. Our second one was -1/3. And these are going to be neither. And the reason is because they do not have opposite signs. All right. And good. All right. We will look at this next one on there. So I don't know what problem number this is. That's okay. We have line 3, 4y equals -27. And we have line 4, 4y equals -21. Right? With both of these, they are, there is no x, which means that they are going to be special lines. They're y equals something. That is a horizontal line. So no x. You can divide by 4. That would get your y by itself, but you don't have the right form. Y equals mx plus b. So you have to just go with the special case. It is going to be a horizontal line because it doesn't have an x. So horizontal line has slope equals 0. Right? This one will also have slope equals 0. So what you have are two horizontal lines. So they are going to be parallel. They're not the same line because these numbers are not identical. So, so the slope is 0, the slope is 0. They're the same, so this would be parallel. Okay, so that was kind of, you had to think outside the box there. All right, we'll do number 5 here, or line 5 and line 6. You're good for the second one because it's already in the proper form. So line 6, you have y equals 3/4 x minus 5. Your slope is 3/4, no work. Right, the other one we'll have to work on a little bit. Line 5 is not in the same form. So we have 6x minus 2y equals -25. This is what we call standard form. You get x and y on one side, constant on the other side. And so we have to isolate the y to read off the slope. So I'm going to subtract 6x from both sides. So I get -2y equals -25 minus 6x. Divide by -2. So we get y equals, this is positive 25 over 2. And this makes a plus 3x. Sorry, I got my color scheme all off there. But all you care about is what is your coefficient of the x. This is your slope here, m equals 3. So this one is going to be neither. Those are not the same, and they are not negative reciprocals. So sometimes that happens. So for line 5, we did no work, and, line 5 we had to work. M is 3. Line 6, we did no work. It's 3/4. So this one is neither. We'll look at this one because we don't have to do any work. Right, so y equals 2/5 x plus 1, and y equals -6 minus 5/2 x. So your y is isolated in both cases. You can read off your slope, even if they're turned around. Slope is always the coefficient of the x. So this one, m, is 2/5. This one, m, is -5/2. Your sign goes with it. Those are flipped over and they have opposite signs. So these are going to be perpendicular. So 2/5, -5/2, and perpendicular. All right, we have a couple of application problems here. They're not hard. Don't be scared by the word problems. I can do this right on here. And hopefully, I'm going to try to use my mouse instead of my stylus, and hopefully it will show up for you. This says, suppose you are in a submarine 45 feet below the surface of the water. So 45, -45 is where you are, right? You are ascending towards the surface of the water. So you're going up. The graph models this situation, and it asks, what is the slope? And slope is giving your rate. So you do have to watch the scale, but we want to move from here, and we want to find where it hits at a corner, but it hits at all the corners, so that's good. So we're going to start here, and we're going to go up, and this was 5 units, up 5, and the horizontal scale is 1. So our vertical change was up 5. So we don't care that it's in the negatives. We cared how much we moved. We moved up. So we moved up 5. So that's positive. And then the other scale is 1, up 5/1. So our slope is 5. So this is the rate. So he's ascending at 5 feet per whatever your unit would be on the other side. All right. It might be minute or second on this other scale, but that's a rate. Okay. And that's what slope gives us, is a rate. So they just wanted us to count and see it on a real situation. All right, and we have one more of those. This one is a stock, and it is going down, so we hope you don't have this stock. And this is not a real one. I mean, it might be real. I don't know. I haven't checked. Okay, so it says this week the price of stock DDD is $18 for each share. And so that is starting here on the y-axis. So that's your y-intercept, right? For the past several weeks, it has been decreasing and may continue. The graph models the price of each share per week. What is the slope of the line? And so your slope from here, you're going to go down, and you want to find when it hits at a corner, and it hits right there. So we're going to go from 18 down to 16, so that is -2. And because your scale here is 2, and this scale is 1, so we're going to go over to the right 1, and we hit the line again. To the right would be positive. So this is -2. So it goes down 2 points for every 1 week. That is your rate, but it just asks us for the slope. There you go. All right, I'm going to take just a minute and switch sections. We have another section today, and this is writing equations of the lines. So we are getting very close to your next test. So make sure you're starting to work on that review and getting all your homework done. Okay, sorry, I'm a little slow here. All right, so Mod 9 Homework 2. Equations of lines. All right, and in this one, Let me just make a couple of little notes here. For your different forms of equation of the line, the one that you will use most often to find the equation of the line is called the point slope form. And it is y minus y1 equals m times x minus x1. And you have to have a slope and a point. And your slope goes here and your point goes into the ones with the subscripts. You keep the regular x and y. So that's the one you plug into the majority of the time to find your equation of the line. The slope-intercept form has y isolated. Right, and standard form, I didn't see any of those ask for standard form, but standard form has x and y on the same side, constant on the other side. Right, and you just do some algebraic manipulations to move them around. This is usually where you start with your slope on one point. This first question, it's trying to lead you. I don't know. It's okay. We'll look at it. All right. It says you are asked to find the line in slope-intercept form. So at the end, they want y equals mx plus b. That's what that means. All right. And it goes through these 2 points. So what they're telling us here is you can find the slope if you have these 2 points. What we're required to have is 1 point and a slope to find the line. We have 2 points, so we're okay with 1 point. We need to use those 2 points to find the slope. So this is asking a step. So it says use this formula to find the y-intercept. That is not it. Right? We don't want the x-intercept. Use 5/3 to find the slope between the 2 points. Right? And we don't want that. And this one says use this formula to find the slope between the 2 points. Well, it would be changing y, so 5 minus 5, that's correct, over 3 minus a negative makes plus. So this one is going to be the choice. Last one. So find your slope. Right? Then you've got a slope and you've got a point. You will go to this equation, point slope form of the line. So plug the slope and the coordinates of 1 point into the point slope form of the line. This is the right choice. Okay, and lastly, you should get the y by itself, so the equation looks like this. Well, when you get y by itself, it doesn't normally look like that. This one might, I don't remember the points. It is going to make the y 0. So it is going to look like that. It's going to be horizontal lines. So normally you would be trying to get y by itself so the equation looks like this, y equals mx plus b. This particular one, they might say that first choice. Let's see what they said. Okay, this would be the standard one. So do this. Okay. This is what happens in that particular example. All right, I should have submitted on those others. Okay. Now we'll get a regular question. So these are the things we'll use. So you need to memorize those, especially this point slope form. Right, in this section, you're going to be writing the equation of the line. Okay, and so if you don't have the slope, you have to figure out what the slope is. And some of them might say parallel or perpendicular or something. So, but you need a slope and 1 point to be able to do it. All right, so this equation of the line with slope equals, so m equals -7/5. It passes through this point 15, -8, and they want us to write the final answer in y equals mx plus b. All right, so we can say that that's how we want at the end. But to begin with, this is a nice standard question. They're giving you slope, they're giving you 1 point. Go to the point slope formula. So y minus y1 equals m times x minus x1. Good idea to say it every time you write it. You're hitting 3 senses. You're writing, you're seeing, and you're hearing yourself. So it will get in your long-term memory faster. Okay, so I have, this will be x1, y1. So I have y minus a -8, which we'll clean up in a minute to make positive. My slope is -7/5. My x1 is 15. All right, so this is y plus 8 equals -7/5 x minus 18. All right, I would clear the fraction. I don't like to do math with fractions, so I'm going to clear this 5 out. So I need to multiply here by 5, here by 5, and here by 5. That will cancel it out. All right, so I have 5y plus 5 times 8 is 40 equals. Over here now, you have to take this -7 and distribute. So -7x plus is 7 times 15, 105. And now you're going to move around and manipulate to get y equals mx plus b. So you want y by itself. So we will subtract the 40. That will leave us 5y equals -7x plus 65. And now you have to divide by 5. Under each piece, when we do lines, we divide under each piece because sometimes they'll simplify. If we had a plain formula, we'd usually do it under the whole thing. All right, so now we can pull our slope away from the x a little bit. 65 divided by 5 goes evenly because it ends in a 5. And so we should clean that up. All right, and this was this one. So this will be -7/5. They had already put the x there for you, plus 13. All right, 3 looks like a nice question, a nice standard question. Right, it says write the equation in slope-intercept form. This one is actually not standard. Has -4, and its y-intercept is 0, -2. You could actually go straight to y equals mx plus b, but it's not a good idea to get that too hard in your head, because the only kind of point you can go straight in for that is if they give you the y-intercept. They did, so that is the b. -2 is the b, -4 is the m. So y equals -4x minus 2. So it saves us some time, but be careful and don't try to use that unless this is the y-intercept. That's the only time you can. All right, let's see. Problem 4. This one asks us to find an equation for the line perpendicular to this line, and it goes through this point. So you're going to have to know about slope here. So here's our line we have. All right, and what we need off of this one is the slope. Y is isolated, so we can read the slope right off. So the slope we have is -1/4. Right? We would like to have a line with the slope that is perpendicular. So the new slope should be flip it over an opposite sign. The new slope should be 4. Right? And then we have to go into the point slope form. You can't go through this the y-intercept or the slope-intercept equation. All right, so we have y minus y1 equals m times x minus x1. Right, and this is our point, so this is x1, y1. And our new slope will be 4. So we have y minus a -9 equals 4 times x minus a -8 I have to be careful jumping and doing that. Right. Minus a negative makes plus. Right, and this one's going to make plus. So y plus 9 equals 4 times x plus 8. All right, so they ask us for the final answer to be in slope-intercept form. So we really are just going to need to move the 9 to get there. We'll have to distribute. So we have 4x plus 32. And we need to subtract the 9. So we get y equals 4x plus 32 minus 9. 12 minus 9 would be 3. So 23. So 4x plus 23. They already had the y equals. So that is part of your equation. Okay, this one is giving us a graph, and it's asking us what is the slope, what is the y-intercept, and to write the equation. So it's not really a standard kind of question. So to find your slope, you have to count, and the points I see 0, -4, and I see 6, -8. All right, so I'm going to try to count from those. So from 0, -4, so I'm going to go down and then over. So I'm going to go down 2 over 1, 2, 3. So down 2 would be -2 over 3. So there's our slope. The y-intercept is the point where the graph crosses the y-axis. So the y-intercept from the picture is 0, -4. Right, so make sure we have those right. -2/3, 0, -4. And now they ask for the equation in slope-intercept form. We actually have the intercept, so we can plug right in there. Y equals -2/3 x, and this will be -4. And it's done. So it's less work than some of them because you didn't have to go to point slope form. All right, let's see what else we have. This one is just going to be some algebra. So we'll practice that. They want you to change this equation into the slope-intercept form. Right, this is point-slope form, and so you have to clear the fraction to do this. So we need to multiply through by 7. So 7 here, 7 here, 7 here. These are going to cancel. So I have 7y minus 28 equals, and then you distribute your 1, x minus 3. And what did they want at the end? Slope-intercept form. So we're going to have to add the 28. And we get 7y equals x. Different signs here, subtract sign of the larger, which would be 25. And then you have to divide by 7 under each term. So you can pull the coefficient away from the x in this first term. It would be 1/7 x. And this plus 25 over 7, that doesn't divide evenly, so just leave it. Your y is now isolated, and that is our goal. So y equals 1/7 x plus 25 over 7. All right, and then they have us go back. This is a standard equation or a standard problem. They're giving us slope. They're giving us a random point, so we go through the point slope form. Let's do one more of that kind, because this really is your standard kind. Right? We are given m equals 2. It is going to pass through 3, 10. They want us to write the final answer in this form, but before you get there, you're going to have to do y minus y1 equals m times x minus x1. Right? This is x1, y1. Right? So y minus 10 equals 2 times x minus 3. Then we have to clean up and isolate the y. So distribute, so 2x minus 6, and then you will add your 10. That's a good equation. All right. This one you have to find your slope first, and then use one of those points. So with your slope formula, y2 minus y1 over x2 minus x1. I'm going to skip that one. Too many of these are just alike. Right, this one they want us to write the equation of the line. Vertical or horizontal lines are special, and they're going to kind of be outside the box. All right, so we have a vertical line which has undefined slope. So it doesn't really fit into the y equals mx plus b. Right, so they want us to write the equation for this. A vertical line is always x equals, and it will be whatever value it's going through. So x equals 4 is a vertical line. All right, here's one that's saying something about parallel. Parallel means the other slope is going to be the same. So let's skip that one. Equation of the line. This is a y-intercept it's giving. You could go, because it's y-intercept, a special point, you could go straight into this form. All right. Both of these are asking for perpendicular. So we'll do one of them. And it's your slope you're going to have to work on. These are very similar questions, actually. So we'll do 12. Our point is 2, 0. Oh, that one is parallel. Let's do the perpendicular one. I'm sorry. Just parallel is going to have the same slope. All right, let's do the perpendicular one. All right, so our point is 1, -2. Our line is going to be perpendicular. That means perpendicular, that symbol. Perpendicular to this line. Right? And so we want to write our equation of the line. And they want point slope form. All right, so the first thing we have to do is figure out the slope of this line. Right, so that means isolate your y. Right, so I'm going to move the 2x to the other side. So I have 3y equals, and when it moves, it's a -2x. -2 minus 2x. We'll divide everything by 3. So y equals -2/3 minus 2/3 x. Okay, and so the slope of that line is -2/3. We want our line to be perpendicular to that, so our slope will be opposite side and flip it over. And now we have a point and we have our slope. The formula is y minus y1 equals m times x minus x1. So this is x1, y1. So y minus a -2 makes y plus 2 minus a negative. Sorry, stuck there for a second. So we've plugged in, I didn't finish plugging in the point. So I plugged in the -2 into the y1. I needed to plug in the 1 and I need to plug in the slope. So 3/2 times x minus 1. This is what I think they want you to show because they said point slope form. Yes. So if you cleaned it up more, they would count you wrong. All right. So very similar. Okay, let's do 18. This is the only one I've seen that asks us to go to standard form. Remember that has x and y on the same side? So this is just going to be algebra. You are not having to plug anything in here. It will want you to clear the fraction. So rewrite this in standard form. So standard form is ax plus by equals c. So I like my x's and y's positive. So I'm going to move that one over here and the constant over there. So I'm going to put 5/3 x. I'm adding it to get it over here. I'm going to keep the y and I'm going to subtract the 1/3. If I subtract it, it's going to be negative. The only other thing you have to do here is clear your fraction. So multiply through by that common denominator, which is a 3. these will cancel. So 5x plus 3y equals -1. This is what is called standard form. Right? So 5x, they already put the x on there, plus 3y equals -1. All right, and they want this one in slope-intercept form. We can do that, and then we'll stop. Okay. So 19. Write the equation at the end in y equals mx plus b form. So slope-intercept form. Here is our equation we're given. All right, and it wants us to state the y-intercept as an ordered pair. Okay. State the slope as an integer. So we have to isolate the y before we can do this. So let's move the 45x to the other side. So we'll have 50y equals, and it doesn't matter, I'm going to just put it at the front. 45x minus 25, right? And then we want to get y by itself. So we're going to divide everything by 50. So we get y equals, we have to reduce this fraction, 45 over 50. So I'm just going to go to my calculator, fraction button, 50, and that is 9/10. And this will be minus 1/2, but we can put it in there. 25 over 50 is 1/2. All right, I'm going to turn that off because it kind of freaks me out when it shows half of it. All right, so they want us to answer the equation in slope-intercept form. That is what we have. Slope-intercept form. And the slope is 9/10. Coefficient of the x, once you go to that form. The y-intercept is going to be this number at the end, but they said to do it in an ordered pair form. For the y-intercept, the x is 0 by definition. So 0, -1/2 should be that, and this one should be 9/10. All right, we'll stop there. Work on this and make sure you memorize all those formulas that you need so it won't be too much at the end. All right, you guys have a great day.